This week, we are going to make a valve assembly. We use valves to control the fluids. In our example, we use metal-to-metal contact in order to prevent the fluid flow. And we use this metal-to-metal contact between the body part and the number 6 of the color. A valve is used in a fluid line to control the fluid flow. In the fluid open position, the valves get lifted by 5 mm from the seat to allow the fluid from the left to right in our example. Figure shows the detail of the screw-down valve. We have a part list on the right side. During our modeling, we are not going to make the parts which are highlighted with the blue box. The sleeve number 5 is mounted on the stem 8 by the screw 9. Valve seat 11 is attached to the collar with number 6. With the screw 12 and the collar 6 is screwed on the sleeve number 5. We are going to just complete the valve assembly. Screw sleeve number 10 is located in the bonnet number. This assembly group is screwed on the valve body number 1. Gland number 4 is located in the bonnet group with the stem number 8 and with packing number 7 seen in this figure. But we do not model this packing group. This packing group prevents the leakage of the fluid from the valve. Gland is secured by the cap nut number 3. Hand wheel 13 is mounted on the stem using the nut 14. During the operation of the hand wheel, the screw number 9 lifts the valve, opens the fluid passage, or screws down the valve to stop the flow from one side to another. The stem number 8 is called actuating screw.
Let's start with the part modeling. The first thing, I have the new part with metric template, standard millimetric IPT. Hit the create button, or you can just double click on it. And the first thing, when we have an open part, I would like to just prefer to have the origin folder open and make the origin point visible and XY plane visible. And after that, we are going to make a sketch about the loft part. We are going to make, and I will try to just change, select an origin point for my figure. Here, what I'm going to do is I will just build my model around this origin point. We have the body part. We first create the body part. Then we are going to add the hexagonal ends around the body part. And we have a fault at this point, and as you see, the 40 millimeter here, it is not fit to this dimension. For this reason, I will just omit the 40 millimeter. I'm going to use 35 millimeter at this point. The first thing, we are going to just start modeling with the body part at the middle point, at the middle of the part. For this reason, we are going to use the loft tool. We use 4 basic commands during modeling in Inventor. These are extrude, revolve, sweep, and loft. For this part, we are going to use the loft tool. We mostly use these two tools during our model, extrude and revolve. For our example, we are going to use the loft tool. We use the loft tool for creating the solids with different cross sections in the body that we cannot use the extrusion tool. In our example, we have circles on each ends, and we have an enlarged circle in the middle side. And we are going to make this example. As you see, we have also a bigger circle in the middle. In our part, we have different sections. And with the extrusion tool and with the path shown here, we cannot make our part with the extrusion tool. For this reason, we would like to just follow the sections in the middle point at these, and we will just follow these sections around the path here. We have 3 sections shown here. Let's start modeling. The first thing that I'm going to use to create is the axis lines around the origin point. For this purpose, I'm going to just create 2 lines, arbitrary lines, and make them attached to the origin point by the coincident constraint. On purpose, I just take the midpoints of the lines and stick them to the origin point. I start by the 8 lines which I'm going to create with the planes that I'm going to use for the loft processes. The first thing that I'm going to just make this dimension with 40 mm. I created this point. I'm going to sketch on that point, and it is about 27 millimeters far from the origin point. I will just create 2 planes on this sketch. In some parts, uh, if you want to just express our dimensions during the creation of the solids, for this reason, we just sometimes create the sketches in order to have their dimensions in the technical drawing. For this reason, I'm going to just make the 2 lines and with the dimensions which I have in the technical drawing. In order to create a plane on a point, I will use the sketch points. For this reason, I will just trim the bottom part of the line which I'm going to use for creating the plane purposes. I need those points during the creation of the plane process. For the point on the other side, I'm going to just create the mirror side of the plane point, which I have created on the left side. In the mirror command, we need two things. The objects to be copied on the other side, we have to select first, then we have to select the second thing, which we use a mirror line. Let's finish our sketch. And in order to see what we are doing in the part 3D drawing, we just choose the orientation box on the top side. Also, I would like to just need for the plane creation, I need a plane parallel passing point. For this reason, I will use the origin point, origin folder planes. In our part, we need 3 origin planes. For this reason, I'm going to add and make them visible to use that sketch, that planes. I will use the plane on a point command. First thing that I'm going to use is I'm going to just select the command, then select the plane, then select the point which I would like to just create a sketch. I first have the command, then select the point, then select the plane in order to create the plane parallel to. I start a sketch on this plane with 35mm diameter. Then I will just create a polygon with 6 sides. I will do the same things on the other side. We will also create another sketch on the other side. But for this purposes, I'm going to use the project line, project geometry command to create the same sketch which we have previously made it. We just finished the two end sections of our loft cone, but we also need another section which is between these two sections, and I will just show you that section on the drawing. We have a big circular section which is passing from the origin point. At this point, when we have drawn our midpoint, midsection here, we need a pathway to define our loft process, and this path must pass within the 3 sections which we are going to draw. In the original figure, we have a typo at this point, which it doesn't fit our part requirement. We have a 55mm radius from the top view, and our dimension, in the midsection, it is not suitable that dimension because it cannot pass that way. For this reason, we are going to ignore that dimension. We also have another path passing from in our part from the bottom side, and we would like to just meet the ends of that part with our sections. Let's create the paths which we have seen on our top view part. We use for this purpose this plane for creation of the pathway. For this, we just create the first meet the ends and passing from the midpoint of the other section. We first create the circle, then get the geometries from the end sections of our objects. Then we will just create the lines passing and starting from that objects, and we will just make tangent to the curve or circle which we have created at the midpoint. We also need starting from the right side of our part. We are not going to use these geometries. For this reason, we will turn them to construction. We define the dimension with 55 and start the lines from the geometries which we have created recently. This is the starting point. We will just create two arbitrary lines, then make them tangent to this 55 millimeter circle. We trim the unnecessary portions of our sketch. We have created a pathway which is passing from back of our part, and we have created that feature. For the visual clearance, I will just close the other sketches which we previously had. We have this pathway, and also I need a pathway on the other side. For this reason, I started a new sketch and do the same things for on the other side. Also, do not forget to have the projection geometries from the circles which we did before. Now we have the two pathways which we see from the top view. We will just create a new pathway which is passing from the bottom side of our part. You can see this pathway I'm just drawing on the paint. For the third pathway, I'm going to use the XY plane to create a sketch on. For path starting and end points, I just take again the project geometries of our circles for starting and ending points. And do not forget to turn them to construction. Our pathway passing from the bottom side is an arc piece, and this arc piece center point is on a line. We just create a line which is passing from the origin point. For this arc piece, we create a circle on this line, and we will just make the trims to get an arc piece. We will create a relationship between this circle and the project geometries which we have just received from the circles and sections. We will just make coincident this circle point passing through these 2 points. We will create a dimensional relationship of this arc piece. We make the trim to get an arc shape. We create the end sections. We create the pathways, but we need another section which is in the middle of these 2 sections. And we are going to start that section by using a midplane between these. We create a circle on the middle plane in origin. As told before, our dimension is not suitable for this arc shape because it must be 55, and this 55 millimeter radius pathway does not fit this dimension. For this reason, I would like to just make a relationship between our paths and with our circle. We will create a relationship by using these pathways, projection, and lines. We will just get a projection on the backside of our pathway. I will use this point and make this one construction in order not to confuse. I will build the relationship between my circle and that point by using the coincident construct. If you use the origin point to create this circle, you may have a fault in your model because we have a difference between the pathway which you are going to create with the bottom pathway and with your circle. At this point, we should have to correct some missing points in our model. For this, we would like to have the bottom pathway passing on our model. For this reason, we have to just make some corrections on our pathway. For this reason, I will just change the order to see the pathway during our modeling or to see our sketch during our modeling. For this reason, I will just shift my pathway, button pathway, and I will just delete the dimensions and redefine that relationship by using the projection of the circle and make this curvature passing from the midpoint or endpoint of the line which I'm going to create. Now we have three sections, three pathways passing with all is true, and we are ready for our loft process. We have the loft tool. On the right table we have the sections, and we just select one by one our sections. This is the section 1, this is the section 2, and this is the section 3. And on the right side we have the rails, which are pathways, and we are going to select one by one. From the top side, on the other side, we just select the rails and add one by one. Also, I will just select the bottom section here. I left the top face pathway empty because it is not fully defined, and I will just create the other things on the top side. By clicking OK, we finish the loft tool. In our technical drawing, we have a wall thickness between the faces of our part. For this, we will just create a shell body by unselecting or just removing the faces from our body which we have created in the loft side. We are going to use a shell command at this point by removing the end faces of our body. We select the faces to remove and we adjust the thickness to 3 mm. At the end faces of our body part, we are going to just create the extrusions, the hexagon extrusions by using the polygon tool. For the polygon, we have an inscribed circle which is 35 mm. We first create that relationship. We can also create that relationship without creating a circle. We use the geometry which we previously created and have the polygon tool tangent to that. We use the six-sided, six faces with the polygon. We use the midpoint, so center point of this polygon. We create a horizontal constraint relationship, one of the sides of our polygon, and we will just make tangent to this circle. After the polygon sketching, we just make an extrusion 13 millimeter. We will make the extrusion full. Then we will just create a hole with the threaded feature. The extrusion on the other side, we are going to use the mirror feature. We just select the mirror. In the mirror selection, we first select the feature to be mirrored on the other side. Then we select the plane, which is in this condition, the plane on the midpoint. From this point, we will just work inside of our body part. For this reason, we will just change our view with the whole section. We will create the two holes with the thread, which is on the left side and on the right side. After the hole creations, we are going to make the body part additions on the top side. After these additions, we are going to just create a wall additions inside of our body. For the body additions on the top side, we will just going to create a sketch on XY plane. To show you better what I'm doing in this sketch, during this sketch, I will just divide the screen into two to show you what I'm going to do with this sketch creation. I start the sketch on XY plane. I'm going to create a full body revolution without a hole. Then we are going to make a hole feature from the top side. For this revolve process, we are going to create two rectangle tools. In the original sketch, we have some dimension missing. For this, we are going to just make our part by using the relationships and the dimensions or the features in our body. We create a dimensional relationship between the first sketch and the total height of our part by just getting a relationship between the circle here and the top side. And we give that dimension by using a projection line from the circle which we have created. The dimension relationship to the top side is 10 plus 4. We give the diameter dimensions which we have seen. We will just give the dimensional constraint to 4 mm at this point. We will make the full revolve by adding a coincident constraint of the left side of the rectangles to the origin line. For revolve sections, we just select two rectangle sections and a revolution axis. At this point, we are going to start the hole creations. After the hole creation, we are going to add the inside body features. We start the hole feature by selecting a surface and moving the hole point and stick that point to the hole here. We have on the top side, we have a threaded feature here, and we will just move our point up to this point. We first change the threaded type and size, and after that we are going to just adjust the blind hole dimensions. Here we have the 10 millimeter threaded length and 10 millimeter hole. At this point I made a mistake and I will change the hole depth without the thread section by selecting a tool command, by selecting the surface which I have created in the revolve section. At this point, I'm going to just change the revolve sketch by using the geometries which I have previously created. For this reason, I'm going to select the project cut edges. At this point, the project geometry is not working. We will continue by creating the profile which we have inside of our body part. We create a new sketch on XY plane. We will create a profile shown in the paint drawing. In order not to have a representation warning about our hull section, we have to save our hull sectional view from the view folder and selecting a new and create a new sectional view. You can also rename that view. We are going to continue the inside profile section. We first make the right side of the part here. During this creation, we do not forget the revolve part at in the midpoint. In order to have the relationship between the dimensional relationship between this profile and the revolve section, we first create the axes. We first create the ring sections in the midpoint. We also give the symmetric relationship between the upper part and the lower part by using the axis lines. The ring in the middle point is 6 mm in height with symmetric condition around the axis. We have the revolve feature and turn it around the axis which we have created. We started a new sketch to have the profile on the right and the left side. We first get the geometry to start with from the top side here. For the fillets inside, we are going to just create the circles here. And we create the tangent relationship with the lines which are coming from the ring and the top side. After combining the lines, we do the trim processes. For other side of our profile, we used offset command. We also give the dimension for this offset. For the left side of our profile, we continue and extending the lines from the right side. We create first the vertical lines, then the fillets, fillet circles. We give the tangent relationship, define the dimensions as we did on the right side. On the left side of our profile, the outer profile is not defined. The inner profile just touches our ring. For this reason, we will just have to create the inner profile with offset command. When using the offset tool, at this point, we have a full profile, but we need some portions of this. For this reason, we will just have the offset profile, offset command, without the loop selection. Please make that selection off. After trimming, we will create a relationship, the inside profile, and stick that to this line by using the coincident constraint. After this trimming, we have lost the tangent relationships. We have to define those relationships with the lines. We would like to extend the lines in order to get a closed loop. Now we are going to just make the extrusions by using the next command. We start the extrusion by selecting the first closed loop areas which we are going to use. Extrusion with toNext command only work in one direction. For the other side, we should also create another extrusion with toNext command. At this point, I would like to show you that we can just ignore the half section view and create a 3/4 section view. For this, we have to select two planes in order to have a 3/4 section by using this tool. Now I can show you what we are doing in the 3D view with the quarter section view better. Again we enter the extrusion command and select the profile, and with toNext command we just hit our extrusion to the front face of our body part. We add the profiles into each other to have a full extrusion with toNext command. We do the extrusion to the front face. We will do the same thing, same extrusion, to the back face of our body part. When we use a sketch in a feature, it automatically disappears. To use that sketch again, we have to make it visible again. We use the same extrusion with toNext command for the other side. We are not going to cut this profile, we will just join and change our direction to the back face of our part. At this point, we are going to just make the ring part in the middle of our part by having a revolve cut with the half section view. We first open the visibility of our sketch and add the ring point with a closed loop area with the rectangle tool. We are going to start the holes on the hexagon extrusions. The sizes of these threaded holes are metric 20 on each side. We get the hole tool, select the face, and the geometry, we will just stick that hole point to the origin point of our figure. We change the dimensions. We have a threaded hole, we have a dimension, and we change our dimension here. And also, we are going to change the depth of our part and of our hole here, which is 13 millimeter, and the threaded length is also 13 millimeter. We do the same hole creation on the other face of our hexagon part. Finally, we are going to give the fillets of our part. For the top side we have a 5 mm, for inside we have 4 mm. We start the fillets with 4 mm, which are inside. If we have a difficulty about the fillets in some positions, we can just rewind our part features by having the end tool. Then we add the fillets which we need to. Then we have again rewind our features back. We have a fault at this point. We are going to please move this face when doing your modeling side. Please move your face to 2 mm to inside. I have forgotten that one. You can also adjust your part view for the modeling side. For this, you have to switch to master view and close the visibilities of the planes or sketches which you have left in the master view. We will continue our part modeling with the other parts. Thank you for listening.